Okay, let's kick things off with a little puzzle. What do the food on your plate, the battery in your car, and the massive steel beams holding up skyscrapers all have in common? I mean, they seem completely unrelated, don't they? Fertilizers for farming, batteries for power, steel for construction. But believe it or not, they are all connected by one single, invisible, and incredibly powerful chemical. And the answer is sulfuric acid, H2SO4. This stuff is like the invisible giant of the industrial world. It's so fundamental that its production volume is literally used as a key indicator of a country's economic health. Let's dive into why. To really get a handle on its impact, you've got to think about scale. I mean, sulfuric acid isn't just another chemical on the shelf. There's a reason it's called the king of chemicals. Its production numbers are just mind-boggling. And this is exactly why economists pay such close attention to it. Think about it. When a country's industries are firing on all cylinders, making more cars, building more stuff, growing more food, they need more sulfuric acid. So a jump in its production, that's a direct signal of a healthy, growing economy. It's like taking the pulse of a nation's industry. But the sheer scale it's tough to wrap your head around. Globally, we crank out 288 million metric tons of this stuff every single year. That's like the weight of over 40 Great Pyramids. So what kind of industrial magic lets us create this much of the so-called king? Well, the secret to this incredible scale is a surprisingly old method known as the contact process. It's the global gold standard for making the highly concentrated sulfuric acid that our modern world absolutely depends on. And get this, it's not some newfangled invention. The process was patented way back in 1831 by a British vinegar merchant of all people, a guy named Peregrine Phillips. His method was just so efficient and so economical that it basically paved the way for the Industrial Revolution to scale up like never before. So how does this recipe actually work? You can think of it as a four-step chemical dance. First, you burn pure sulfur to create sulfur dioxide gas. Next, and this is the most important part, that gas gets converted into sulfur trioxide. But here's the really clever bit. You can't just add water to it. The reaction would be incredibly violent, almost explosive. So instead, the sulfur trioxide is first dissolved in sulfuric acid that's already been made, creating this super concentrated oily liquid called oleum. Then, and only then, is the oleum carefully diluted with water to get our final highly concentrated product. It's pretty ingenious. Now, the real hero of this whole process, the secret sauce, really, is the catalyst they use in step 2. Vanadium 5 oxide. It basically acts like a chemical matchmaker, speeding up the reaction like crazy without getting used up itself. It's this one material that makes the entire process efficient enough to work on a global scale. Okay, so we're making all this acid. Where does it all go? This is where you really start to see just how deeply this one chemical is woven into the very fabric of our modern world. And the numbers here, they tell a fascinating story. A staggering 80%, 80% of all sulfuric acid goes into just one industry, making fertilizer. The other 20% is split up between all those other crucial jobs, from processing metals to powering our batteries. But that 80%, that's the real headline. So why is it so incredibly vital for fertilizers? Well, it's all about unlocking a nutrient that plants desperately need, phosphate. Now, phosphate is everywhere. It's abundant in rocks. But in that rocky form, plants can't absorb it at all. Sulfuric acid is the key. It literally dissolves the rock, changing the phosphate into a water-soluble form that plants can drink up through their roots. Without this one chemical reaction, modern agriculture as we know it just wouldn't exist. But its reach extends so much farther than the farm. It's the battery acid in your car. It's used for something called steel pickling, which is just a cool term for cleaning all the rusted gunk off steel before it's used in buildings and cars. And on top of that, it's a foundational building block for everything from detergents and dyes to other important chemicals. It really is an industrial workhorse. But, as you can probably imagine, a chemical this powerful is also incredibly dangerous. Anything that can dissolve solid rock and clean steel, well, it needs to be handled with extreme care and a whole lot of respect. This is the universal hazard symbol for corrosive substances. When you see this GHS05 symbol, it's a very clear, very serious warning. This chemical will cause severe, irreversible damage on contact. And let me be clear, that is not an exaggeration. This is a direct quote from official safety data sheets. It's a blunt, no-nonsense warning about the very real dangers of this chemical. We're talking severe, deep tissue burns and permanent eye damage, even blindness. This is why the safety protocols are so incredibly strict and completely non-negotiable. Full protective gear, gloves, clothing, face shield is an absolute must. And there's a golden rule in chemistry that you never, ever break. You always add acid to water slowly, never the other way around. If you add water to concentrated acid, it can generate so much heat so fast that the water instantly flashes into steam, creating a dangerous, explosive splash of acid. So, what's the big takeaway here? It's that sulfuric acid is truly a chemical of two faces. It is both an essential creator and a potent destroyer. On one side, it's the creator. It's the chemical that helps feed billions of people and helps power our modern world. But on the other side, it's the corroder. It's a hazardous substance that demands our utmost respect and caution. It's a perfect example of a double-edged sword, a tool that is absolutely indispensable for our way of life, but one that has to be handled with incredible care. Which leaves us with a final, fascinating question to think about. Is there any part of our modern world that this king of chemicals doesn't touch? From our food, to our cars, to the buildings we live and work in, it's this powerful, hidden force that shapes our lives in countless ways. Thanks for joining me for this explainer.